Hey everyone, here's your lesson on dilations not about the origin. It's not too difficult to figure it out. However, if you've never seen it before, it might just be something new to you. We're going to start with these three graphs up here, and what you need is the graph paper in the back of the room. If you have your own graph paper, you're welcome to use that as well. So we're just going to practice dilating points right now, and we're not literally going to make the point bigger or smaller. We're going to adjust the coordinates based off of a scale factor. So this first one, we're going to dilate this point right here, we'll call it point A, by a scale factor of 1/3. And our center of dilation is going to be 0, 0, so I'll mark that as well. On your graph, if you want to sketch this picture as well, that would be great for following along. And to figure out where our new point's going to go based off of our scale factor is just looking at the horizontal distance and the vertical distance our A point is away from the center of origin. So if I look now, it looks like our vertical distance is 3 units away from our center of dilation. Our horizontal distance is also 3 units away. So essentially what you're doing is dilating the distances the points are away from the origin. So we know our scale factor is 1/3. So our new horizontal distance is going to be 3 times 1/3, which is just 1. Vertical distance, 3 times 1/3, which is also 1. So our new point A, or A prime, is going to be at 1, 1, right here. 3, 3 became 1, 1, our dilation of 1/3. Now we're going to move on to the next example, and this is one where we do not have a center of 0, 0, the origin. We have a dilation that's not about the origin, which is 4, 6. So if you hear my dog, by the way, he's just chewing on a bone down by me right now, and he's chewing very loudly. Let's put our center of dilation at 4, 6. So you're under your new graph now. That's our center of dilation. We'll name this blue point, not A prime, excuse me. Let's just name it A. This will be point A. And again, we're going to analyze the vertical and horizontal distance the point A is away from the center, and then from there we'll find the new distance based off of our scale factor, which in this case is 2. So this point A, I wrote A prime again, this point A is 3, our vertical distance is 3 away from the center of dilation. The horizontal distance is 1 unit. Now, since our scale factor is 2, we're going to multiply the distances away from our, multiply these distances by our scale factor. So our new horizontal distance is 1 times our scale factor of 2. So we know it's going to be 2 away. Our vertical scale factor, or our vertical distance is 3, and our scale factor is 2, so we're going to do 3 times 2 to get 6. So our new point is going to be not at 2, 6. This is why it's a little different when we have it about, not about the origin. This is just saying that our new horizontal distance is going to be 2 rather than 1 space. Our new vertical distance will be 6 rather than 3 spaces. So what that's going to look like is this. So instead of counting to 3 like we did here for our vertical distance, 1, 2, 3, 4, 5, 6, and then our horizontal distance is 2, 1, 2. So we know our point, a double prime in this case, is located right there. And I want to draw your attention to something that you did yesterday. If we look at this distance, the distance from A to our center of dilation, A prime to our center of dilation is double that distance. And that makes sense since our dilation scale factor is by 2. Let's try our third one. So we're going to dilate this point by 2/3, and our center is -6, -3. So this is our center of dilation. If on your graph you want to mark that as center, that would be totally fine. Center. Okay. So again, we're looking for our horizontal distance from this point. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. So our horizontal distance is 9 away, and all I did was count this segment right here, how many units there were. Our vertical distance, we're running from 3 to -3. That is a vertical distance of 6. Now, our scale factor is 2/3. So that doesn't mean we take 2/3 of our point here. We'll call this point B. It just means that we're taking the distance away from the center of dilation, the horizontal and vertical distance. We're going to cut that into 2/3. So our horizontal distance of 9 is going to be multiplied by 2/3. And 2/3 of 9, that'd be 18 divided by 3, which is 6. Our vertical distance of 6 multiplied by 2/3. 6 times 2 is 12. 12 divided by 3 is 4. So our new horizontal distance from that center of dilation is going to be 6 units, and our new vertical distance is going to be 4. So let's mark that. So we want our vertical distance to be 4. So 1, 2, 3, 4. And then our horizontal distance is 6. 1, 2, 3, 4, 5, 6. There we go. So there's our new point B prime. And again, think about this. Our scale factor is 2/3. This distance is like 2 parts to 1 part, making 3 all the way up. This distance here is double this distance. So it even actually makes sense when you connect the center from to the original point and the image point. 2/3, 2 parts to 1 part there. The last example we're going to do together is one with an actual shape. So let's go ahead and look at that. We're going to, shapes are the two you're going to do on your own. We're going to do the dilation on this line right here. So our center of dilation is 3, 4, and again, you're going to write this line on one of your graphs. 3, 4 is our center of dilation. And we're going to look at the horizontal distance from that dilation, or from one of the points to that center of dilation. So I'm going to label this point A, this point B. We can see that our vertical distance from the center of dilation to our point is 2. And our horizontal distance is just 1. Again, we're referencing 2 and 1 right here. Since we know our scale factor is 2, we're going to be dilating that by 2. We know that our vertical distance, our new vertical distance, is going to increase to 4, because we're going to do the 2 times 2 to make 4. Our new horizontal distance is going to be 2 times 1, which is going to give us 2. So now our point A and our point B, you only need to technically find it for 1 point though. Our new vertical distance will be 4, new horizontal distance will be 2, so let's mark that on our paper. This vertical distance of 2 now becomes 4, and this distance of 1 now becomes 2. So our new point, A prime, is right here. Now when we look at point B, its vertical distance is none. If you look, we're right on the same line as the center of dilation. But our horizontal distance right now is 1, 2, 3, 4, 5. So if we double that, we get 10. So point B is going to be 10 away, or point B prime is going to be 10 away from our center of dilation rather than just 5 away. So let's increase that. 1, 2, 3, 4, 5. Here's our B prime point. And we can connect those 2 points with a line. Perfect. And if we look at this line, A prime, B prime, this line segment, it's about half the size of AB, which is exactly what we wanted because our dilation scale factor was 2. What I want you to do with number 5 and number 6 is go ahead and do those on your paper. We'll check them tomorrow in class. Just pause the video and make those 2 graphs for yourself. If you're having any trouble seeing the points, I can write those out for you. Both of these triangles, if we labeled them A, B, C, A is at 2, 2, B is at 4, 2, and C is at 2, 4. So those are those points for you for both of them. You'll be doing two different dilations. One, your triangle will get larger because our scale factor is 2. One, your triangle will get smaller because our scale factor is 1/2. Good luck.